So let's pick up right where we left off. Number 4, we do not have a common denominator. Now, to really understand number 4, we have to understand something, just like any other question in math, understand something simple that's related to it, and you'll be able to understand a more advanced math question. So how would I do 1/2 plus 1/3? Well, you need a common denominator, right? So on this guy, we also need a common denominator. But over here, how do we get this common denominator? I know that you guys know it's 6, but how did we get that common denominator? Like, what was the math to be able to get that 6?
Find the greatest common factor.
Greatest common factor, or also known as the least common multiple? Yeah, okay. But what's the math that went on to get the 6? I multiplied them together, right? Okay, so check this out. Maybe instead of writing it as 6 as the LCD, let me write down 2 times 3 as a denominator and 2 times 3 as a denominator. I know that sounds a little ridiculous, but if I wanted to change the 2 to become a 2 times 3, what's missing? The times 3, right? So what you do to the bottom, you do to the top. So you get a 3 up here. And if I wanted to change this 3 to become a 2 times 3, what's missing? The times 2, right? So times 2, you get the 2 up here. And now that we have a common denominator, I know we're used to seeing the common denominator as 6. But let's just call the common denominator 2 times 3. It'll make sense in a couple of seconds here. Okay, so now that I have a common denominator, and the common denominator is 2 times 3, now I'm able to add the top with the top, and we'll get 5 over 2 times 3, right? Now, why do I leave the 6 as a 2 times 3? Because maybe this 5 is not a 5. Maybe it ends up being a 4 or a 6, and then you could cancel the 6 with the 3 or cancel the 4 with the 2. So in other words, I left the 6 in factored form. Okay, so that's what we're going to do over here. We need a common denominator, and the common denominator will be both of these multiplied together, right? Kind of like the common denominator of 2 and 3 is 6. The common denominator here, we're going to multiply them together. But you know what? I'm not even going to actually multiply them. I'm going to write them together with multiplication, and that'll be my LCD. So check this out. The left fraction, the right fraction, the plus right in the middle. On the left fraction, the common denominator will be x plus 3 times x minus 2. And the same for the right fraction. It's going to be the same thing, x plus 3 times x minus 2. Okay, it was similar to what we did over here. When I said, what's the common denominator of 2 and 3? Yeah, we said 6, but let's just leave it as 2 times 3. In other words, I could distribute x times x and get a quadratic trinomial as my common denominator, but I'm not going to do that. I'm going to just leave them together with multiplication, just in case we could cancel out anything at the end. Okay, so this is our common denominator. This is our common denominator. How do we change this x plus 3 to become x plus 3 times x minus 2? You have to multiply by x minus 2, right? So what you do to the bottom, you do to the top. We need to multiply by x minus 2. So up on top, I'm going to distribute 2 times x and get 2x, and then 2 times negative 2 and get negative 4. Are you with me? Okay, let's look at the next one. How do I change the x minus 2 to the common denominator x minus 2 times x plus 3? What's missing up here? The x plus 3. So let me write down this binomial times x plus 3. Now, what I do to the bottom, I must do to the top, so I need to multiply the top by x plus 3 also. Are you with me? So up on top, when I distribute x times x, I want to get x squared. X times 3, I want to get 3x. And ladies and gentlemen, we have changed both fractions that had different denominators. We changed both fractions to new fractions with a common denominator, which means now I'm able to actually add the top with the top. So the next step here would be to rewrite our answer with that LCD, the denominator, x plus 3 times x minus 2. And of course, on top, we're going to be combining the terms that are alike. We're going to add the numerators. So since we want it in standard form, let's start with the x squared. There's nothing else to combine it with, so I have x squared as my first term. And then the next one are our x's. We have a 2x here plus plus a 3x. So a positive 2x plus a positive 3x, we're going to get a positive 5x. Are you with me? And the final constant value on the numerator is going to be the minus 4 left over, right? This minus 4 right here, there's nothing to add it with, so let me just bring it down, minus 4. Are you with me? All right. Now, what we're supposed to do here is attempt to factor the quadratic trinomial. So just a quick couple of seconds. What times what is negative 4 that if I add together is positive 5? It doesn't work, right? Negative 4 times 1, that'll combine together to give you negative 3, not positive 5. Or positive 4 times negative 1, that doesn't give you 5 either. So this top one's not factorable. Now, if you wanted to, now you could distribute. But the reason why we leave it like this in factored form is because maybe we could factor this one, which could continue canceling. So I recommend just leave it in factored form. Even if you can't cancel, I would say this is your answer. Of course, on a multiple choice test, if you saw a quadratic trinomial down here, then maybe it's a good idea, then it would be a good idea to distribute and change this to a quadratic trinomial. But on an open response quiz, I would just leave it like this, factored form. Okie doke? So, I think we understand that we could get a common denominator by multiplying both denominators together. However, we don't want to jump straight to that. Let's consider that our last resort. Okay? Here's a tip. It says, when you don't have a common denominator, try and factor the denominators to see what your LCD will be, your least common denominator. Don't just multiply them and say that that's your common denominator. So for example, let's go to some basic addition and subtraction of fractions. Now, what is the LCD right here? 20. Could you use 40 as a common denominator? Yes, you could, but there's going to be higher numbers involved. There's going to be more math involved. So it's always a good idea to go with your LCD, your lowest common denominator, which we know is 20, right? Now, on this section, I know we could do the LCD in our head, 20, but I would like to show you a method on how to find the LCD. That way you could apply that method when you have variable expressions down there. So let's factor the 4. If you were to factor the 4, you'd have a 2 times 2. If you were to factor the 10, you'd have what? 2 times 5. Thanks, guys. All right. Anyway, the 4 is factored to 2 times 2, and the 10 is factored to 2 times 5. Now, whenever you have the same thing repeated in both, this is what I want to do. I want to circle it, and I want to write that down as the first part of my LCD. And what about the rest? I'm going to bring down the rest also. Times 2 times 5. What I'm teaching you here is a method to find your LCD. Okay, now obviously when you guys look at 4 and 10, you think, oh, the LCD is 20. That's easy. But here's a method that I want you to apply so we could apply it in future variable expressions. So what do? We factor, we have it in factored form, and now we circle what appears in both and write it once, and then whatever else is left, you bring it down and write it there with multiplication. So think about it. 2 times 2 times 5, that will give you the LCD 20. Does that make sense? So this is just a method I want you to start practicing. Okay, now I'm not even going to work through the rest of this. I mean, I'm supposed to say, okay, it's 20, and what do I do to the bottom to get 20? I need to multiply by 5, so I get 15 over 20, which is the same thing as 3 over 4, plus, and how do I change 10 to become 20? Well, we multiply it by 2, you get a 2 up here, and your final answer is going to be 17 over 20, right? 17 over 20. Now, but that's not what we really want to focus on this section, is being able to use that method to find the LCD, the lowest common denominator. And what's the method I want you to use? I want you to factor each of the denominators and then write down what's in common, write it down once, and then bring down everything else. So, for example, the 8, I could rewrite that as what? 2 times 4, but 4 could be broken down to 2 times 2, right? So let's completely factor it. 2 times 2 times 2. That's 8. How about 6? Well, that's 2 times 3. Yay? Okay, so is there anything in common in the first denominator and the second denominator? Yeah, there's 1 2 right here, and there's another 2 right here. So my LCD, my least common denominator, is going to have that 2 right there. Does that make sense? Okay, and the rest I'm going to bring down. The rest I'm going to bring down. Okay, so this 2 right here, I'm going to bring it down. This 2 right here, I'm going to bring it down. And this 3 over here, I'm going to bring it down. So what is our LCD going to be according to the numbers that I have here with a bunch of multiplication between them? What's 2 times 2 times 2 times 3? 24. So your LCD is 24. Your LCD is 24. Okay? So our LCD, 24 right there, 24 right there. And then you go back and say, okay, what do I do to the 8 to get 24? Oh, I multiply by 3. Multiply by 3, so I get a 3 up here. And you say, what do I do to 6 to get 24? Oh, I multiply by 4. So I multiply by 4, and I get a 4 up here. And of course, there's subtraction going on between those two. So what's our final answer going to be? 3 take away 4 is -1 over 24. There's our answer. But again, what I really want you to focus in on this section is using that method of factoring the denominators, completely factoring, to be able to get your LCD by writing down what's in common in both and then bringing down the rest. Again, writing down what's in common in both and bringing down the rest. So let's factor 12 completely. Like, we don't want to say 6 times 2 because 6 could be broken down further. So what does 12 become? I mean, if you want to write 6 times 2, go for it. But the 6, you're going to have to rewrite it as what? 3 times 2, right? And don't forget about the other 2. So 12 is really 3 times 2 times 2. You guys following me? Yay?
Yes.
Okay, how about the 8? What could you rewrite 8 as? 2 times 2 times 2. Yay? Okay, so again, step 1, factor the denominator completely. Okay? Step 2, what's in common in both? Oh, there's a 2 right here, and there's a 2 over here. So let me write down those 2 together as one single 2. Does that make sense? Okay, what else is in common in both? Well, there's another 2 right here, and there's another 2 right there. So let me write down another 2 right there. And now what about what's left over? You have to bring that down also. So let's bring down the 3 and bring down the 2. So ladies and gentlemen, this is your common denominator, your least common denominator, right? What is 2 times 2? That's 4. What's 4 times 3? That's 12. What's 12 times 2? It's 24. So our LCD is 24. Does that make sense? Okay, so once again, we factored the 12 completely as 3 times 2 times 2. We factored the 8 completely as 2 times 2 times 2. You write down what's in common. This 2, circle it, bring it down as one single 2. Circle this one, circle that one, bring it down as one single 2. Take the leftover 3, take the leftover 2, put it all together with multiplication. That automatically gives you your LCD. Now, yes, we could have looked at this original fraction and said, oh, the common denominator is 96 if I multiply 12 times 8. But that's not the best method. That's not your lowest common denominator. You're not just going to jump to multiplying them together. Factor, factor, write down what's in common. The 2's, bring down what's left. The 3 and the 2, you'll have your LCD 24. And then you could go back and ask yourself, how do I get 24? 12 times 2 is 24, so times 2 is 10 up here. And then 8 times 3 is 24, times 3 will give you a 3 up here. And of course, we are subtracting between the two, so our final answer is 7 over 24. So, I hope we understand this method of finding the LCD. On the next video, we're going to apply this method of finding the LCD when we have variable expressions like these examples down here, 1, 2, 3, and 4.